everybody, here's today's lesson. We're going to graph, as I promised you, we're going to graph some tangents today. On Friday, we actually, well, hey, first, let's get our note sheets out. Let's turn to page 37 of the notes, please. Page 37 of the note sheets. On Friday, we did problem C. We graphed a tangent. You already have this done. This is problem C on the notes. You have this graphed. And we talked about the fact that the tangent has an asymptote at negative 1/2 pi and positive 1/2 pi, and just squiggles right through the origin. It has a period of pi from negative 1/2 to positive 1/2. That's a whole pi. And it has no amplitude, because unlike the sine and the cosine, which have heights and depths, the tangent does not. The tangent goes up forever and ever and down forever and ever. So the normal regular tangent looks like this. This is our baseline picture. These are our baseline labels. This is the origin right here. So now we're going to use that picture and our knowledge of what these extra numbers do as we start graphing on page 37 of your notes. So we skipped all the tangent problems. We're going back to fill those in now. So I'm going to do problem F. F is y equals negative tangent x. Now, there are no numbers stuck in the problem. That means absolutely no labels will change. So I'm still going to have an asymptote at negative pi over 2 and another asymptote at positive pi over 2. Do not be confused. No labels have changed because you didn't put any numbers into the problem. What did change, though, is you have a negative. Remember that a negative in front of your function turns it upside down. So instead of the tangent starting down and ending up, it is going to, you guessed it, start up and end down. So that is how you would graph a negative tangent. Now look at problem I, because it does have a number put in there. Now you'll remember that a number in that position divides the period. So I have a tangent curve, asymptote and asymptote. It's not negative, so it has its just normal picture. But the normal period is pi. This number divides the period. So my period is pi divided by 1/4, which is pi times 4 over 1, or 4 pi. Remember, dividing by a fraction, you multiply by the reciprocal. So pi divided by 1/4 would be pi times 4 over 1, or 4 pi. Now be very careful. That does not mean this is 4 pi. That means that all of your labels, and the good news is in a tangent you only have 2, have been timesed by 4. So if you take negative 1/2 times 4, what do you get? You get negative 4 over 2, which is negative 2 pi. If you take positive 1/2 and times it by 4, you get positive 2 pi. Remember that the tangent is the distance from, or the tangent, the period is the distance from start to finish. So from negative 2 all the way to positive 2 is a distance of 4. These labels are not 4s. To get these labels, figure out what you do to your period. You divide it by 1/4 or times it by 4, and then do that to these labels. Let's try the next one. It would be L. Again, we got an asymptote here and an asymptote here, and we have a regular old tangent curve. This too, now listen carefully. I don't want you to be confused. This too multiplies the amplitude. Does a tangent have amplitude? No. So that too does stretch the picture, but it doesn't impact your labels. You don't have any labels. So you can pretty much ignore it. It does stretch your picture, but I don't want you to worry about that. We're not labeling any verticals, so we can't really mark that, so don't worry about it. This, though, you do have to worry about, because what does that number do? That number divides your period. Now, your period is supposed to be pi, but it's been divided by a fifth, which makes it now 5 pi. Because dividing by a fifth is the same as timesing by 5. This is not 5 pi. To get these labels, remember that everything horizontally gets timesed by 5. So negative 1/2 times 5 would be negative 5/2, and positive 1/2 times 5 would be positive 5/2. If you think about it for a minute, this should make sense. If you go this way negative 2 or this way 2.5, and this way 2.5, your total distance is indeed 5. The labels aren't 5. The total distance is 5. To get the labels, you simply multiply your base labels by 5 in this case. M. Letter M. Oops, that's not right. Okay, we have a tangent curve. It's positive, so we know we're going to have an asymptote here and an asymptote here, and a nice positive tangent curve. There it is. Now all you have to do is figure out these labels. You have no amplitude. Tangents do not have amplitude. And your period is supposed to be pi, but you have been divided by 10. Your regular labels are negative 1/2 pi and positive 1/2 pi. This time, everything horizontally has been divided by 10. Instead of, these are fractions. Instead of dividing by 10, I'm going to multiply them by 1/10. Remember, dividing by 10 is the same as multiplying by 1/10. So if I do that, if I multiply these guys by 1/10, then I will have negative pi over 20 and positive pi over 20 as my labels. Keep in mind, kids, that this number in a tangent curve, this number is never a label. This number is the distance from asymptote to asymptote. If you go back 1/20 and forward 1/20, that's a total of 2/20, which is where the 1/10 comes in. All right, to kind of wrap this up a little bit, I know we didn't get to all of the problems, so I'm going to go ahead and try do a few more. I can't remember which ones we did and didn't do. So I'm going to go ahead and do K and N right now. They are not tangents, but we need practice with our sines and cosines too. So Let me go ahead and do K and N right now. Now, in order to do K, I'm going to put my cosine curve over here. This is my normal cosine curve with my normal labels. If you're confused a little bit, I'm only going to do these 2 examples in this video. Go back and watch the video of last night's homework, what was the sheet called? Worksheet 4.4 to 4.5. We did 1 to 10 and 21 to 25, and that's some good graphing, and I did graph all of those, so you can go back and look at that if you want to. This is the standard cosine. So I'm graphing a cosine. With these numbers stuck in it. So I remember that this number multiplies my amplitude. So I'm going to go up to a 4th and down to a 4th. So here's my cosine curve. Starts at the top, ends at the top. And my labels have been adjusted because this number right here divides the period. So my period is supposed to be 2 pi. But I have been divided by a 4th. 2 pi divided by a 4th is 2 pi times 4, which is 8 pi. This tells me, dividing by a 4th or multiplying by 4, tells me that every one of these labels has been times by 4. Every single one of them. That makes the last one 8 pi and the middle one 4 pi. 4 times a half, that first one would be 2 pi, and 4 times 1 1/2, that one would be 6 pi. These are always evenly spaced. So you can see there 2, 4, 6, 8 for a period, a total distance of 8 pi. And our amplitude is indeed a 4th. Remember, tangents do not have amplitude, but sines and cosines do. All right, I'll wrap this up with number N, or letter N. Now, in order to sketch this, let's keep in mind what a normal sine curve looks like. This is the one we've memorized. It's got a hill and a valley. It's got the same standard labels as the cosine, same amplitude, same period. There it is. That's what I'm shooting for over here. So I see it's positive, so it's going to be hill and then valley. I see that my amplitude is still 1. It hasn't changed. The only way to change the amplitude is to put a number out here in front. We didn't. Therefore, the amplitude stays 1. The period is supposed to be 2 pi, but it has been divided by 2/7. This number divides the period. So the period started out as 2 pi, but it's been divided by 2/7, which means it's been multiplied by 7 halves, which gives me a total period of 7 pi. Every label is going to get timesed by 7 halves. So keep in mind what they are originally. They're pi over 2, pi, 3 pi over 2, and 2 pi. Those are the standard labels for the sine and cosine. But each of these numbers is going to get timesed by 7 halves. So when I take pi over 2 times 7 halves, I'm going to get 7 pi over 4. when I take pi times 7/2, I just get 7/2 pi, or 7 pi over 2. 3 pi over 2 times 7/2 gives me 21 pi over 4. And 2 pi times 7/2, I already did that arithmetic, that gives me 7 pi. Again, do not freak out because of the fractions. You can do this. It is not an issue for you at all. You will be fine. You can do it. All right.